Welcome everyone. This is the second episode of Progress.FM. The last chapter was with Yeet, where we saw the projects he was working on, especially this Fog of War chess NPC based game. We started to learn and speak about NPC, and fortunately for us, we have our guest today, Takamichi, who is from the PSC team and has been here in the ZK Vietnam residency, researching and exploring all of these NPC applications. So by the end of the session, it would be really nice if we have a much better understanding of all of this niche world. So Takamichi, I would lend it to you. Feel free to introduce yourself.
Okay, thank you, Carlos. Hello, my name is Takamichi, and as Carlos said, I'm looking for the different variety of applications that we can use MPC for. And during this Vietnamese residency, we found some ideas. So yeah, I will share it maybe in this talk. Yeah. Thank you.
So there's a lot of ideas on MPC, right? But let's start from the beginning maybe. Could you give us a description of what MPC is and why is it useful for us?
Okay, so MPC is short for secure multi-party computation, that you can do some computation with somebody else, and you both have secret inputs, and you don't have to reveal the secret inputs to each other, but you can jointly or collectively compute some function using those secret inputs. So that's, I think, the most simple description of the secure multi-party computation. Yeah.
So why are we looking into that? On which areas can this help us? This is exactly, I think, what you have been looking for during these weeks. So
Yes.
please give us an introduction to all of that.
Okay. So I think it's a good idea to compare with ZK Snarks or ZKP things, because ZKP things is for single party to prove something on his or her private input, right? He calculates something using that private input and provides some proof about it. But in MPC, we can do that with multi-party setting, meaning that we both have some secrets. So it can be applicable. We can do more things, theoretically more things than ZKP, but in a real world, it's not that efficient, and it's I think it's pretty early stages we are now. So we need much more development to make it into real use cases. Yeah, that's, I think, the current situations.
When you say right now it's not that efficient, are you referring to performance to do this computation, or efficient in the sense of it's really, really hard to develop them and build them?
It's
sense?
in performance sense.
Performance.
So MPC is we consider two aspects of performance. One is communications, and one is computation. Right. So the communication is how many communications we need each other to execute certain function, and the computation is how much computations we each other needs to do on the local machines. Right? So computation wise, I think it's not that a problem, but communication, when it comes to communication, it requires much more things if it comes to involving many parties. So yeah, I think that's the current big problem.
So kind of what I've gathered over the past couple weeks, which like I guess makes sense now that I'm thinking about it. We've talked about it, but it's like ZK and homomorphic encryption and all that just kind of fall under MPC. Like MPC is the larger umbrella. Is that correct?
I don't think so.
No?
It's yeah, because we can combine these different tools to do many things, many things. It's not, I would say, completely under the umbrella of that.
Okay.
Yeah, it's
But overlapping.
yes,
Okay.
somehow overlapping, and also we can get a powerful tool with combining those together.
Cool.
So, could you now you've basically explained us kind of the limitations and all of these different kind of words and techniques and things that we have been listening on this and the last session. So it would be nice now if we can dive into basically the research that you have been doing during these weeks. I see that you have basically defined different topics where MPC applications would be helpful, or there's at least a lot of potential. So please feel free to enlighten us on that.
Okay. So in this residency period, we come up with some ideas and some groups of ideas. Let me give some example. So first group is this social graphs and reputation or trust scores thing. So what this does is, so given certain network that many peers in, and we want to calculate this global trust scores so that we can use that to accept some messages from some peer or something like that. And to calculate the global this trust score, we have algorithm called eigentrust, or we have other algorithms too, but yeah, let's talk about this eigentrust. So when running the eigentrust algorithm, we all have a local trust score to each other. Right? I have some score to you, I have some scores to Tyler, and I have some score to you. And we all reveal that to the world. Then collect that at one place, then do some computation over it to get what's world is seeing. Right? So this is a very brief introduction of the eigentrust, but you actually in real life you don't want to reveal how much I trust you or how much I trust this person, right?
Yeah.
So in such case, MPC is really useful because we can calculate some value, but without revealing the input that I have. Okay. So that's MPC is useful for in this kind of social graph and trust score things. There's another example that is civil rank, which is basically it's a civil detection algorithm in a network, and it requires some the peer revealing. You need to reveal the peers that you have and do some random walk until you get to some civil this sub network, some group of the network. And in such case, also we don't want to reveal that what we have, but you still want to calculate something. You still want to find something is civil or not. So the idea is that we want to calculate, or you want to calculate something, but you don't want to reveal data. And there is also another party that think in the same way, right? In such case, we can use the MPC in this social graph and reputation or trust score things. Do you have something?
I have some question here. So the question that I have is, I clearly see the value with the eigentrust example that you mentioned, right? I guess in the civil rank detection is that you basically don't want to reveal your peers, as far as I understand, but at the same time you are trying to prove that you should not be able to perform a civil attack, or what is exactly what you're trying to compute in the civil rank?
So yeah, in the civil rank algorithm, what you do is to detect that the ultimate goal is to detect which peer is civil or not. So you give some count of the random walk, and if the count, the number that the random walk passed you is small enough, then you might be civil. Yeah, something like that.
It's like a probability, right?
Yes,
like a
yes,
percentage.
yes.
It's a number
Probability algorithm.
from 0 to 1, and basically, if I were to repeat, like the times that a connection passes through me, it's like not
Yes,
civil.
yes. So, so sorry, I forgot to mention one thing that is very important is that you start random walk from a trustful peer.
Mhm.
So the idea is that trustful peer don't is not neighbor of the civil.
Mhm.
This is the basic idea.
Mhm.
So you start you select this trustful peers first, and do start random walk from those peers, and we count up the numbers that random walk passes. Then use that number to see if this peer is civil or not.
Is this a new idea that came with MPC?
No.
Or is this a problem that MPC kind of like can fit really well?
I think these algorithms are not from MPC.
Mhm.
It's already there, and we think this might MPC might fit
Mhm.
to secure some privacies.
Mhm.
The peers.
I guess to wrap up this example, it will be useful for maybe some of our listeners to understand what is a civil attack and why do we want to know if someone is civil or not in the network. So could you do a brief explanation of?
All right. So civil attack, as far as I know, is an attack that a user create thousands of account or addresses, or let's say like users that belongs to one person, and use those thousands of accounts to attack some service or something. Yeah, that's civil attack.
So to put it on some perspective, basically what you're trying to say is someone creates an insane amount of identities in a peer-to-peer network, trying to make it so that another user that is behaving correctly fills the buckets of peers that knows with all of these fake accounts, so that the only messages that this peer receives are indeed from your fake accounts and not from separate people, right?
Yes, exactly. Thank
Okay.
you. That's a great explanation.
And in a Web 2 world would be like Twitter bots, like the
Yeah.
influence voting.
Yes,
or
yes.
Oh, that's a nice
Facebook.
way to see it.
Yeah, like the
That's
Twitter
really nice.
account have thousands of followers, but no contents in the feed, right? But
Yeah.
I think that may be a civil.
Yeah. So some of the problems with that would be like quadratic voting,
Yes.
quadratic funding,
Yes,
yes,
exactly.
universal basic income,
Yes,
stuff like
yes.
that. So like if you can play multiple parts,
Yeah.
multiple people online, then there's no fairness.
I wasn't
right?
seeing that. Oh, that's
Yeah,
really
yeah.
nice. That's really nice.
So the term Sybil comes from this woman that had multiple personalities. That it basically like her life devolved into like you not even being able to know who the real one is anymore. It's
Wow.
just
Wow.
many identities, and like she didn't even know the difference between all of them.
Oh, wow.
That was like the first study of multiple personality disorder.
Oh, wow.
That's
I didn't know
interesting.
Wow.
I heard that there is a movie of that.
Yeah.
Yeah.
Civil, right?
Yeah. The Wikipedia is also an interesting read.
Yeah.
So we have another group that you shared with us before, and it's machine learning, statistical analysis. what can you tell us about that? Where can we find use cases under this category?
Okay, so I think this category is really interesting because we also have this approach called zero knowledge machine learning in ZKP world, and how MPC work with that ZK machine learning thing is I think it's really interesting. So before diving into the MPC thing, let me just briefly introduce what ZK machine learning does. So what ZK machine learning do is it can do many things, but basically they do two things about machine learnings. Which first one is they have private machine learning model, and they have public input. Then they can compute on that model and provide some proof that this output is generated from using this private model and public input, and you can verify it afterwards. And the second thing is public model and private input. So you have this public machine learning model, and you want to infer some using the model with your private data, for example, medical data or financial records or anything, and output can be verified as well. So these are the two very interesting things that we can do with the ZK machine learning. And when using MPC, I thought it is also possible to do private model and private input things.
That's nice.
Right. And I think MPC with machine learning have a history. They have something related to maybe federated learning thing, or learning with many parties that have different set of data that trains single machine learning model. And these things let us do some private model and private input, but we can verify the output then using both these techniques. So, yeah.
Go on, please, Tyler.
One of the things that I've kind of overheard that I think is really interesting for the private model and private input would be like some government provides a model for authenticating passports, and then you can prove you have a passport without ever showing anyone your passport.
Yeah.
Which I think that
is
a super cool concept. Yeah.
So I think that what would be the difference of trying to implement this with CK versus MPC?
Okay, so if you want to use a ZK machine learning, you have to state some relation of the public inputs and private inputs, right? So you need to state what, for example, if you want to do private model and public input, then you have you can state something like you have this private model that infer on this public input output something, right? Like this, right? But if you do both private in ZK world, and I think it doesn't make sense because you don't state anything, but you just can have the private model and private input and calculate something output, but everybody don't know that what the model is or what the input is.
Yeah.
So
someone can just take that proof and then use it anywhere, and you don't know. There's no tying it to anything.
Yeah. So in this case, see if I understand, the secret that the government has is the model.
Yes.
And the secret that I have is my passport information. And the public output is the proof that I own a passport from this government.
Yes. Nice. Something like that.
Because kind of what I imagine is we can also not leak the model, because that will allow anyone to see the weights of the model.
Yes.
Hence, be able to come up with a way to verify passports unlimitedly, to put it on something right?
Cheap.
Exactly. That makes complete sense.
Yeah. So that's, I think it's really interesting with machine learning and MPC and ZKP.
Definitely.
So there's other categories that you showed us, and I think we are reserving one for the end, as is the one that you have been exploring the most. So would you like to go on any other kind of category, or would you prefer to go directly into the?
I prefer to go directly because I'm not
Let's
really
go for
using-
it. Let's go for it.
Yeah.
So the second group that you told us about of use cases comes from negotiations, votings, and auctions. So please go ahead and explain us why MPC can really help on those topics.
Okay. So I think why this specific construction is very useful is that we can generate something that enforce users to do some on-chain activities. So let me explain this private negotiation thing. So this involves two-party. This is a two-party multi-party computation. So you and me. Okay. So we do something, some computation on our private inputs, secret inputs we have. For example, if we want to trade some tokens each other, and we want to compare the price that we want to trade on.
Mhm.
Right? So this is like a traditional negotiation thing.
Yep.
And we don't want to reveal the price until we not until what is it? We don't want to reveal the price, but we just want to see the result if the price matches or not.
Mm-hmm.
That's the only thing that we want to know. But we don't reveal the price if the match fails. So I don't learn your price if that match didn't make.
So that's really interesting, because that means that if I want to trade whatever it is with Andy, if I make the first offer, he already gains knowledge of which is kind of my range, maybe,
Yes.
and he can behave in relation to that, right? And we're trying to do the complete opposite thing, which is let's try to be fair and say which is the amount that we think makes sense, and then start from there, trying to see if we match at some point, but without allowing anyone to gain knowledge.
Yes.
So the question that this, at least in me, makes is that, okay, I kind of understand that for a first round, right? Okay, I'm negotiating with Andy and I'm selling a pen and he's buying it, right? So I put my price and it's 50 cents and he's just willing to pay 30 cents for it. So we don't match. What happens now? How do I know if I need to bring the price down, or how can we figure? I mean, for the price, it's decently easy because the seller always goes down.
Yeah.
So it kind of makes sense. But I can imagine that this can be extrapolated to other things. So how do we continue?
Okay, so this protocol is nothing does nothing other than that, comparing the price. So we don't have a way of doing this using this multi-party, because but we can do it because if we have something like compare the not equally check, but this
More than.
more than
Okay.
check.
Yeah.
A range.
Range check,
Yeah.
or more than check. And we also can do it in the circuit. So the circuit, what we want to calculate, what the function looks like is a more general thing that we can do many things in the circuit, but we jointly evaluate the function and we have output. So this is the really abstract construction of this MPC thing, private negotiation thing. And so the answer is we don't have a way of knowing how we should modify the price afterwards or not.
So
Yeah, it's really. I think it's really a usability. It affects the usability of the application that we can build with multi-party computation. But yeah, as long as this thing, how this thing works is like that.
could you do like? Is this the same thing as the chess thing, where you basically have like a list of items and then you see if there's some intersection? Like, could you, if you're talking about salary negotiation, like you could do like $5,000 increments or something, and then see if there's some overlap, some intersection.
The chess thing is a different thing because it uses specific special machine learning, not machine learning, NPC, right? So the what chess thing do is PSI, right? Private set intersection. So it can only check the intersection of the private set, but nothing more than that. But using this general, for example, gobbling circuit thing, we can do arbitrary computation in that with that two private inputs.
Okay. So this is using garbled circuits.
Oh yes, so it's more expressive than that. And I think we also can do the private set intersection using this garbled circuit thing.
Okay. So I'm a tiny bit familiar with garbled circuits, as in I know they exist. And I've talked to Jordan on the TLS Notary team about it a tiny bit. Like I don't know much. He's tried to explain it. I've forgotten most of it already. But is that essentially just homomorphic encryption?
No.
It's so what's the difference there?
So gobbling circuit is it's basically binary circuit, but encrypted. So you first have like a certain binary circuit, and you want to evaluate the circuit with someone else, but have private inputs each other, but don't want to reveal that private input to each other. And in certain case, you encrypt this binary circuit so that the other party does not learn your private input, but still can compute. The other party can compute with the private input, his private input, using this encryption scheme. And we exchange some keys to decrypt a certain gate.
Okay.
Does it make sense?
Yeah. I think what will also help us, at least me, because I don't know anything on the topic, to be honest, is what are those binary circuits? Are we talking about like circuits that do AND and OR only?
Yes.
Okay, so it's literally binary.
Or XOR and NOT. These things.
Okay. So in this sense, like CKPs and NPCs share like the language in terms of like the building blocks are circuits.
Yes, circuits.
Okay, and how do you call, like in CK we have proof systems. Is there any equivalent on the NPC world? Is it like schemes or protocols or?
Yes, I think there are multiple NPC schemes, like garbled circuit. We also have the secret sharing based NPC, which basically create shares of private inputs and pass it to the other party and do the same thing from all the parties, then calculate something using those shares. This is also one scheme of the MPC. I think those two are the main general multi-party computation scheme.
The second one sounds familiar to Shamir secret
Yes,
exactly. That is used in our line.
Yeah. Interesting. So the linear secret sharing scheme is using it can use Shamir secret sharing if you want some thresholding property, or you can also use some just additive secret share. You can just split to add up to some private inputs. Yeah. Something like that.
Cool. So you're talking about like I generate a private share, I put it through the circuit, it goes to you, you can add your share, and then we have some combined thing. Is that?
No, it
Okay.
it works like we have this agreed upon circuit first, right? And we have shares, and we know how to evaluate the circuit, right? And the most thing that we want to do is do operations locally with the shares.
Okay.
So if you have this multiplication gate, addition gate, you can just add shares locally. Then the result of the addition is also a share of the output of the addition gate. Right?
Okay.
This is because it's a linear map.
Right.
Okay.
But when it comes to multiplication, you need some communication with the people, because it's you cannot just multiply your shares locally. It doesn't make sense. So you need to have some intermediary values that in order to do the multiplication gate using the linear secret sharing.
Okay.
So I've been in like the workshops related to MPC, and I've listened already a couple of times what you just said, which is we can do addition, but we cannot multiply, right? But at least to my knowledge, multiplication is just adding n times, right? Or at least can be seen as it.
Yes.
So why is that we cannot multiply
Okay.
if we can add?
So you said multiplication is you add up n times, right?
Mhm.
But you don't know n. So that's why. If you know n beforehand, so we call it a constant multiplication, then you can do it. But you don't have. You have to know the n. So that's also shared with the people.
So that would mean in the real world that you would need to construct a circuit based on the inputs that you are getting, and since the inputs are shares only, you have no way to actually construct the correct amount of steps to do this multiplication. Would that be like a fair comparison?
So do you mean the cost of the multiplication?
Like if you have like a circuit, like a physical circuit, right?
Physical.
But the shape of the circuit depends on the inputs, which is what the multiplication is about, right? It's like you basically need to put more gates depending on your input, but you don't have the input, you have a share of it, so you don't know which the input is, so you cannot construct that in any way. Is that kind of the...
So I think if like multiplication is implemented like add n times, then it's the case. But we have this multiplication gate do relatively efficiently.
Mm-hmm.
So it is called Beaver's triple. So we prepare some other shares that we use to calculate the multiplication. So using those other shares, which is not the input into the circuit, but we use that to calculate the intermediary values to construct the shares of output of the multiplication.
That makes sense.
But the difficult thing is to generate those shares also have some problem, because it is you cannot use that same shares multiple times. You can just use it one time, and you have to use another thing for the different multiplication gate. So basically you need to have the shares for the number of the multiplication gates in the circuit.
Okay.
So that's also a problem in this scheme.
So can you not reuse the shares because of security, or
Yes.
okay,
Okay.
not just how it works?
Yes.
Or security. Okay, that makes sense.
I guess zooming out a little bit to the techniques or the main techniques that you told us about. I've been also hearing a lot the term NPC in the head.
Okay.
So, what is that, and how does this work?
All right. So MPC in the head. Actually, I learned that last week.
Okay,
From
just,
the internet.
just an intuition would be nice.
Yeah.
So what it does is it actually does not involve multi-party. It involves single party, and you do computation as you do with multi-party setting in your computer. So you have multiple threads, let's say. Then those threads act as like the parties in the setting and calculate some output. And along with these computation, you have these transcripts that describes how each thread have this transcript, how they compute this, how they communicate, and use those transcript. You can make some zero knowledge proof about the computation.
Okay.
Probabilistically, I think. Yeah, that's as far as I know. Yeah, but I'm not sure.
Yeah, I'll be very curious to see what we can prove about the computation and why wouldn't you do it straight without NPC?
Right. I think it's more like not you want to compute with multiple party, but you want to generate some ZKP. So that's the point.
Okay.
I think it's
I see.
So it's more oriented to basically make a proof
Yes.
about an NPC computation. Okay. Okay.
I really wanted to ask a bit more on the. You mentioned like one bottleneck is not performance but communication.
Yes.
What about communication? Is it that each time that you send information back and forth to all the parties, like the network gets clogged, or is it like a lot of data that has been sent? Like what's the limit here, and maybe what are options to reduce that or techniques to reduce the communication?
Yeah, that's. I think that's really important question. So we have these two different schemes I explained. First one is coupling circuit, and second was linear secret sharing based ones. So starting with the linear secret sharing schemes, it requires the intermediate values for each multiplication gate, right? So we have this phase called offline phase, so which generates those shares, right? So if we have this big circuits with many multiplication gate, we need to generate these intermediary values beforehand. And in that phase, because we create as a share, we need to, broadcast, let's say.
Okay.
We need to, everybody have to have that values.
Yep.
Right? So it requires many communication costs. And existing some solution or mitigation of that is use some trusted third party. Yeah, to generate things and just broadcast to many people. But I think this doesn't make sense because right.
It's the purpose.
Yeah. So if you want to do this purely like peer-to-peer based, this requires many communications. But I think the size of the thing that we need to, send is not that big. And also when calculating the multiplication gate, we also need to reveal the intermediary shares with each other to calculate the multiplication gate. So it also requires communication when also evaluating the circuit. Okay. Yeah. So I think that's the two main overhead in this linear secret sharing based scheme. And in a gobbling circuit, it doesn't require much communication cost in terms of the times you have to communicate with.
Mm-hmm.
Because gobbling circuit is basically it's for two party, so you can just communicate with the other party,
Mm-hmm.
and the person who gobble the circuit he just encrypt the circuit and send it to the other party,
Mm-hmm.
and that's it.
Okay.
And we have some key exchange thing, but not that big. Yeah, so
Okay.
but the encrypted circuit is very big. So here is a problem with the size of the circuit. Yeah.
When you say very big, what do you mean? Are you talking about like 10 megs or like a gig? Like,
I think yeah, it depends, but you gig thing.
wow.
So order of
think-
gigabytes.
I mean,
Wow.
I don't know.
Like,
Yeah.
large.
Like
Yeah,
a movie,
very
like
large.
downloading a movie, basically,
Yeah.
or even more.
Yeah.
Wow.
Hmm.
That's
But
really
there is also approach that you stream the circuit.
Right.
okay.
Yeah, so that you can do it like memory efficiently.
Mm-hmm.
So that's also how that's possible because it's two party setting.
Mm-hmm.
Goblin circuit has this solution.
Okay. So for the linear shares, it's more about latency and all the peers communicating, and then
Yes.
garbled circuits, it's
Yes.
huge circuit sizes.
Yeah,
Okay.
definitely.
Cool. Interesting.
I have a question in regards of that, and it's more personal about your opinion.
Okay.
Do you think the issue is more on the networking side in regards of we should have like better protocols, or like we should come up with better ideas on how to connect via peer-to-peer, or that we should have better protocols and more optimized things in the NPC world so that networking is not an issue anymore? Because networking works to do basically everything that we do in the actual world, right?
Yeah.
So
Yes.
I'm not sure after all of those years if someone hasn't come up with something that's significantly faster. I'm not sure how much you can improve on that area.
In my opinion, it's more on the network issue we have to think about. I think it's the way protocol works is not significantly improved in these years, I think. So that's why what I'm doing is to looking for applications that we can do with existing discovery circuit toolings, and how we can do interesting and very important thing regarding and also combination with the ZKP things. Yeah. I think that's the using with ZKP is not very deeply researched area in this, so I think it's really worth trying.
That sounds really nice. Coming back to the use cases, so we've spoken about salary negotiation, right? But I know that there's more things and more topics and more use cases in that second category. So could you please also name some of the others that you have came up with, and if there's anything in particular of any of them that you think it would be really nice to
I think this is not really particular use cases, but I would say this is more like the construction thing that the private negotiation is, because you can use this private negotiation in many areas. I don't know. Yeah, because this scheme is, I think, did I explain this private negotiation thing from at
So
till the end?
you explained us basically that you would be able to negotiate with someone without revealing
Yes.
your stuff. We understood that we can do that for the salary, but I see that there's like more things that you're naming here, right?
Okay, so
Mm-hmm.
okay, so we have we missed the last part of this scheme. So we can compare it, or we can negotiate with the salary, right? And after negotiating the salary, we can enforce the two party to do something on chain. Yes.
Hmm.
So the interesting part is, I think, is this part, because after you agreed upon some price, you want to do some transaction on chain to exchange tokens, right? So we can construct such Goblin circuit that have both of our own signatures with the price, so that we can use that to do some on-chain activities, or arbitrarily on-chain activities, let's say. So, for example, the salary thing is put aside. What about some machine learning model we can use in Goblin circuit? So we have this private machine learning model and private input, and evaluate the machine learning model, and output has signatures, so that you can use the output of the model to do something on chain. And and the important feature is that both of us can generate the output, meaning that, like the traditional Goblin circuit, you generate a circuit, and you pass the circuit, encrypt the circuit, and send it to the other party, and the other party evaluate the circuit using the circuit. But he can choose if he tell me the output or not.
Yeah.
Right? So to avoid that, so we both generate a circuit, and we both encrypt the circuit with each private input. Then we send each other, right? So that we can both evaluate the same function, and we generate same output with same signatures. So you cannot just not giving the output like a traditional ones, so that you both can enforce that
Right.
on-chain transactions involving
So
two parties.
this stops someone from being able to like probe a system over and over and over until they can figure out whatever best price they could possibly get.
Yes.
Right. Okay. That's cool.
That's really cool.
Yeah. This is what I missed.
That's super
this is-
clever.
Yeah, and this is really general and abstract scheme that we can use in many applications, I think.
Yeah.
So my next step will be to looking for this. What can we use this for? Yeah, that salary negotiation or maybe price negotiation is one example, and TKML is also the other example. But there should be more applications that we can use this scheme, I think. So yeah, that's
I'll
why.
think about that and I'll let you know.
Yeah.
I love thinking.
Please, yeah. This
I
is-
love thinking about stuff like that.
Yeah, this is really cool thing. I think we can do with MPC.
Yeah.
That's really nice. Also, you basically said you will now you will now basically explore new use cases, new ideas. So, speaking of the future, how do you see the ecosystem of MPC in like the next years? Like, what are your expectations? What would you like to see? What do you think we will see?
Okay. I think because my interest is like combination with MPC and TKP, so I want to see more such interesting applications come out, and also the tooling. We have this MPC tooling, but it's not very useful. We have this developing this bunch of improving ZKP toolings, right? So I hope that we can utilize both existing tools that we developed like these years to make something really interesting.
How are you prototyping this stuff now? Like, if there's a lack of dev tooling and all of that, what do you?
So actually, this idea just came up in this residency. So we didn't start anything yet, but I think what we do first is to develop tooling. Yeah. So for example, one thing is that when using a governing circuit, we have this circuit expression, but it's totally different from the ones from CKP world, right? But we have this very many circuit implementation in CKP world. So if it's possible to port that to use in the MPC world, we can use this very many code bases that we already have in this MPC setting. For example, ZK machine learning model is developed as Circum circuit, and we can use that Circum ZK machine learning model in MPC. It's gonna be really cool thing, I think. So yeah, the compatibility or porting of the circuit is one.
So you're thinking like a LLVM layer, like where you write Circom at like a higher level, and then you can compile it to some other
Or
format.
transpiler.
Yeah, maybe
Yeah.
transpiler or
Okay.
maybe IR thing, or I don't know yet, but yeah,
Okay.
just an idea. Yeah.
That's crazy. Are there any DSLs for MPC right now?
Yes.
Yeah.
I
Really?
think so.
Wow, I wasn't expecting that.
Yeah, I wasn't either.
That's really
Oh,
cool.
do you mean DSL, right? For the DSL.
Yeah,
Yeah.
domain
Yeah, I think
specific
so.
language.
Yes,
Interesting.
but yeah, I think like a Python like syntax, or
Okay.
they also have many other things, but not compatible with the circuit.
Do you have any name so we can maybe later search and add it to the notes? for this?
Oh, so I think it's fair to name some frameworks of the
Yep.
MPCs. So first, very famous one is MP Space. This is MP-SPDZ. So we call it MP Space. It's for the linear secret sharing scheme, and also have some governing circuit implementation. And also Scale Mamba is another framework. Scale Mamba.
Interesting.
And there are many different frameworks.
Yeah.
But you can find it in the awesome MPC repo in GitHub. Yeah, basically, yeah, you can just look it
I
up.
like that name.
Yeah, awesome MPC. Yeah.
Cool. So I have a final thought that came to me basically. So we have been developing a lot of circuits, as you say, in the ZKP world, right? And basically, we have already dealt with the issue that binary stuff is really expensive to do in arithmetic circuits, which is completely the opposite of what happens in the CPU. Maybe I misunderstand a bit the issue, so just correct me if I'm wrong, but with tools like Halo 2 and stuff like that, you could indeed encode binary operations already for bytes, for example, or even for bits if you're at that level, and you could just do lookups to prove any amount of things. Am I can we assume that maybe this is a possible path to explore?
I think yes, that's a possible path. Yeah,
Okay.
and I think there is also some approach that we lift this binary circuit to arithmetic circuit and gobbling circuit protocol level.
Mm-hmm.
But I'm not sure if it's efficient enough to do. But I need to look into detail. But yeah, there's I think many possible ways to utilize
That's nice.
basic thing.
It feels like the CK world is gonna help a lot the NPC world.
Yes,
And eventually as well on the other
Yeah,
way,
yeah,
like
yeah.
things discovered, created in the NPC world will teach back on the CK.
That's really cool. Yeah.
So I guess we will wrap up here. Thank you very much, Takamichi, for
Thank
being
you.
with us, entrusting this this experiment that we are doing.
Yeah.
We highly appreciate your time. We hope we can get together in some time and learn more about the progress that has been happening during this period. And to our listeners, we will be soon with another chapter.
Yeah.
Mm-hmm.
Probably early next week, I guess. 'Cause we have plans tomorrow night and Friday night and Saturday, probably Sunday.
Yeah.
So let's wrap it up here. Thank you,
Thank you,
everyone.
Takamichi.
Thank you for having me. Bye.